The paper titled, CRISP, Cognitive Restructuring of Negative Thoughts Through Multi-Turn Supportive Dialogues focuses on using artificial intelligence, specifically large language models, to help people manage negative thoughts in a therapeutic way. Cognitive restructuring, or CR, is a key technique in psychotherapy that involves identifying distorted, negative thoughts and replacing them with more balanced, positive ones. This process typically happens through conversations, often in multi-turn dialogues, where a therapist guides the individual step by step. The authors highlight that negative thoughts stem from cognitive distortions, which can skew a person's view of reality and contribute to mental health issues like depression or suicidal ideation. For instance, someone might think, "I'm not good enough," after facing rejections, even if that's not entirely accurate. CR, as described by psychologists like Aaron Beck, helps by exploring these thoughts in a supportive dialogue, ultimately leading to healthier perspectives. The paper points out a pressing need for innovative solutions because of the global shortage of mental health clinicians and the stigma that often prevents people from seeking help. This has led to the development of human-LLM interactive psychotherapy, where large language models assist in the CR process. However, existing approaches fall short. Some simply rewrite negative thoughts into positive ones in a single step, while others use fixed dialogue patterns or one-shot workflows that don't mimic the nuanced, iterative nature of real therapy. To address these limitations, the researchers propose a new framework called CRDial. This framework is designed to create more effective multi-turn dialogues by incorporating specific stages for identifying and restructuring negative thoughts. First, there's an identification stage, where the AI helps the user pinpoint their negative beliefs through probing questions and reflections. Then, the restructuring stage involves challenging those beliefs and guiding the user toward more helpful alternatives. CRDial also integrates sentence-level supportive conversation strategies to make the interaction feel empathetic and encouraging. For example, it might use restatements to confirm what the user is saying, affirmations to build confidence, or questions to gently explore deeper emotions. Additionally, the framework includes a multi-channel loop mechanism, which allows for iterative CR. This means the conversation can loop back to earlier stages if needed, ensuring that thoughts are thoroughly addressed rather than rushed. Using this CRDial framework, the team distilled a large-scale, high-quality bilingual dialogue dataset called CRISP. This dataset was generated from large language models and includes examples of multi-turn conversations in both English and another language, likely Chinese based on the author's affiliations. The dialogues are carefully designed to demonstrate effective CR, with elements like empathetic responses and progressive restructuring. From this dataset, they trained conversational LLMs called CRISPers, available in 7 billion and 14 billion parameter scales. These models are fine-tuned to handle CR tasks, making them more specialized for therapeutic dialogues compared to general LLMs. The paper includes extensive human evaluations to assess CRISPR's performance. In pointwise evaluations, experts rated the model's responses for accuracy and helpfulness, finding them superior to baselines. Pairwise comparisons showed that users preferred CRISPR's outputs over those from other systems. Finally, in intervention evaluations, the models were tested in simulated therapy scenarios, where they demonstrated better outcomes in reducing negative thoughts and promoting positive restructuring. For a concrete example, consider the dialogue provided in the paper. It starts with a user expressing overwhelm from paper rejections and advisor feedback, leading to thoughts like, "I'm not cut out for academia." The AI responds with supportive strategies. It restates the user's feelings to show understanding, asks questions to explore the roots of their doubts, and provides reassurance by highlighting their progress. As the conversation progresses, it helps restructure the thought to something more positive, like focusing on small steps and past successes. This illustrates how CRDial enables a dynamic, back-and-forth process that feels like a real therapeutic session. Overall, this work advances the field by making CR more accessible through AI, with the CRISP dataset and CRISPR's models offering scalable tools for mental health support. The authors from institutions like Tsinghua University and Harvard emphasize the potential for these technologies to complement human therapists, reducing barriers to care. Their repository provides resources for further exploration, underscoring the practical applications of this research.